So we're going to talk a little bit about systems engineering and kind of give a little summary to start with. So as you look at the median salaries, it's very comparable to mechanical engineers. They're very close. There happens to be a higher job growth in systems engineering than in mechanical engineers, but both of them make very good salaries. So we all know what mechanical engineers build. They build all sorts of cool contraptions, things like this. So the question is what do systems engineers make? And this problem has perplexed me and caused problems all within systems engineering for years. I didn't learn about systems engineering until I was in my master's degree. First time I ever heard it. I had to go to California to even hear of the name. And the problem is that system engineers make nothing. You can't hold up an engine, you can't hold open a car, anything like that. They literally make nothing. What we do is systems engineers make the products you enjoy better, cheaper, faster, things like that. And so what happens is when you go into a factory, you see a factory. A systems engineer goes into a factory and you walk in after them and you still see a factory. You see absolutely no change at all. But the factory happens to make 5 to 10% more money. And so there's a reason that people don't really understand what systems engineering is because there's no real tangible good that you can say. You said, oh, what do we do? Well, we changed this machine out for a new machine and added 3 more employees here and took 2 employees away from here. And that made the facility, service, whatever it is, far more productive. Okay, so as you look at systems engineering, the belief is to try and improve efficiency. Okay, and at the core of systems belief are a couple beliefs. The world's composed of systems. Okay, and all systems are kind of broken, and you have the tools to fix them. There's a lot of different systems out there. One of my favorite one is the education system. Okay, how do you get students to learn more? How do you build degree programs that are beneficial to employers and employees and grad students that are manageable and add value to people's lives? And so I spent a lot of time studying the educational system. It's one of my favorite systems. It's probably why I'm in academia. But as you look at it, anytime you're improving a system, sometimes you spend too long trying to prove it. You don't get the benefit out of it. And so you have to end up using just common sense and trying to make sure that whatever effort you put in, you're always gaining more than that back out. So at the heart of systems engineering to me is mathematical decision making. Okay, what happens if a small company has 0 inventory, or any company for a really long time? Well, they go bankrupt. Okay, so you look at the opposite end. What happens if the store has millions of units of inventory? Well, they can't store it, they can't sell it all. Some of it spoils, goes bad, and they also go bankrupt. And as you look at systems engineering, this is the core of almost all systems. Too little is bad, too much is bad. How to use math and science to try and find the optimal solution to all these different problems. And that's basically where you live in the systems engineering world. Okay. As a systems engineer, we're trying to, I call it a transformation system. You have a bunch of inputs coming in, you have product, could be a material or a service, and you have waste coming out. Okay. And a lot of stuff in systems engineering has gone more towards the service sector lately, whether it's a hospital. Product coming in is now people, product going out is healthier people, things like that. And so you look at all these things and decreasing labor, decreasing energy, decreasing money, capital, and increasing the product out is kind of where we try and improve things. Okay. And so that is basically where systems engineering is. As a formal definition, it's a methodical, multidisciplinary approach for the design, realization, technical management, operations, and a retirement of a system. So you really look from like start to when you try and retire the system entirely. And you're trying to make it as efficient across there. And you really have to have kind of this global view if you're going to be a very good systems engineer. As you look at systems engineering, you can't cover that all in one area. So you have a bunch of areas. You get individuals. How do you manage and lead people so that they work harder, better, more efficient? Same time, you don't want people getting injured, so you get the whole ergonomics of it. You know, how long can somebody sit in front of the computer? What should their chair be like? Things like that. Another area is data analysis. How do you evaluate data, identify trends, statistical analysis? You know, you don't just want to be flying by the seat of your pants. It's very important. We always find data. We're engineers after all. We want to be able to make sure we're making informed decisions, and that's critical for everybody. On the service manufacturing side, how can you serve customers better? What's the quality of service? Can you manufacture parts cheaper, faster, things of that nature. Operations research, that's the one I like the best. Using computers and tools to find optimal solutions. That'd be that inventory thing. How do you find the best decision? Can you prove it's the best decision? Are there other ways? And that gets applied across all sorts of sectors. So those are kind of the full bulk areas of systems engineering. Okay. Things that I find as benefits of systems engineering is the ability to transfer your tools. In a lot of industries, you might be kind of pigeonholed into whatever you're doing. With a systems engineering background, you're like, I'm really good at designing efficient systems. So you go over and work for a hospital for a while and you get really annoyed at all the doctors because they're a little bit too arrogant or something like that. And then you go over and work for a logistics company and you're trying to route trucks faster or better or things like that. And then you can go off into like a communications company. And fundamentally, all companies want people who make good decisions, who take an inefficient system and make it better. And so when you're a systems engineer, you have the ability not just to be really good at this, but to dramatically change your career midstream and go work for something that's totally different, learn something brand new, makes it really fun. At the same time, we don't have a lot of lab classes, minimal lab time because you're not really doing that many experiments. A lot of them are just other things you do. Most times you can explain what you're doing to your mom or dad, which is nice. It's not very complicated. Well, here's this thing, here's what we did. An interesting fact that is really still surprising to me is that over half of all systems engineering degrees in the US are given out at the grad level. Okay, if you look at mechanical engineering, for every one undergrad, for every 4 undergrads, they give out 1 grad. At the systems engineering, it's 1 undergrad and then like 1.1 grad degrees. It really is a grad degree. And so what happens is a lot of undergrads go out, they get an undergrad engineering degree and they say, I don't know how to lead people. I don't know how to design a more efficient system. And they will come back from a different engineering discipline and do a systems engineering degree or something in that effort to try and get themselves more into leadership. Okay. And one of the most important aspects of systems engineering is the ability to work with people. If I can save a company $1 million and I can't convince anybody to believe me, I've wasted my time, I've wasted the company's time. And so one of the fundamental skills we will certainly try and build in any systems engineering class is how to present stuff so that people will believe you and your efforts to improve a system won't be in vain, because that just annoys you and annoys the company. And we really want to graduate people who are very good at making systems better. So truly this system, this info system is about classes. Okay. We just got hired. We would like more students in our classes. Okay. Between the two of us, we're teaching 4 classes: fundamentals of systems engineering and integration. Those are the 2 classes in the core requirements of the systems certificate. And Pedro will talk more about that. There are 2 elective classes that weren't on the books less than like 2 months ago. Okay. Pedro's teaching the production systems operations class and I teach the systems simulations class. So we're kind of going to cover those. My systems engineering and integration class, that's the capstone class of the certificate. So anybody in that has probably already taken a couple of other classes. So there's not much sense in talking about that. You've made it to that point. You're probably taking the class to get the certificate anyway. Okay. As you look at system simulations, basically what you do is you try and build a factory, maybe a hospital or something like that. Parts flow through it and you try and make a more efficient system. So you've got this little graphic down here in the bottom down here. And basically that is a representative of a factory. And what you do is you run it and there is a long line in, we will say, framing. And they go through and say, well, what happens if we had an extra employee there? What happened to the line? Did we actually get more product through, or did we just increase our employment without any more production because then all the parts got stopped someplace down? And so you'll go through, you'll try and model a factory or something like that. And then you will try and optimize as you go through and figure out best ways to optimize. And that is my elective class. And Pedro gets the rest of the presentation.
Sure do. So still talking about classes here. Then this next one really is what I like to call my baby. A little bit of what you do in Dr. Easton's class using simulation tools. You will see some of it here, but taking advantage of more analytical methods, let's say. The beauty of mathematics associated with what happens inside a production facility. We start the semester sort of talking about how to analyze the flow of production lines, then discuss perhaps ways of better organizing everything physically within that facility, and then drop the discussion on flow production lines and start talking about paste assembly lines, which is a huge deal. I always get students that took my classes in former semester asking for my materials on paste assembly lines, because this is out there and you're going to come across assembly lines at some point in your engineering career. But ultimately, towards the end of the semester, we sort of branch out. We go beyond the four walls of a facility and start talking about where to locate that facilities in a given geographical area and how to interconnect them by means of logistical systems, freight transportation, etc. And I'm really confident that you're going to find these materials very useful, and not only useful, but interesting as well. It's fun to learn them as you venture in your engineering career. If you have questions about anything that is covered in this class, please do get in touch with me. I really want to see students taking production systems this semester, because it is something that I have a lot of fun doing, and I want to make sure that we establish here in the systems engineering efforts in the mechanical engineering department. We have a draft of a syllabus for all the courses we're discussing here today. You can get them from the website, and if you need a copy directly from us, please drop us a note in our emails, and we'll be happy to communicate and answer questions about anything here. We've talked a whole lot about courses, but what is the benefits of taking all of them? And as we said before, as part of the systems engineering efforts that the department is pursuing here, you can take advantage of being awarded a systems engineering certificate. We've designed it in such a way that upon completion, students should be able to much better understand how to manage complex systems, and really systems of any kind. Even though we are under the roof of a mechanical engineering department here, every single engineer out there in the University of Utah will take advantage of these classes that we're offering here. The department now has regular faculty to lead the effort in systems engineering. These courses will be available every regular semester and summer terms as well. So do start planning which ones you want to take. Talk to your advisors. Whether you are a graduate, undergraduate student, we have seats left and we want to see you there. We do have a list of learning outcomes, of course, associated with this certificate program. Our curriculum is being developed in such a way that I would say each of these outcomes will be, in a way or another, dealt with by all these courses that you were already introduced to here today. It's a very comprehensive program. We don't want to make it specific to industrial engineering. We don't want to make it specific to mechanical engineering. A chemical engineer can come over and learn a whole bunch from us. Any other engineering discipline out there is welcome to join us and get a little more familiar with what is the science of systems engineering. And as you see down there in the bottom, the good news is that if you're interested, you can apply right now and enroll for classes that are going to start as soon as August 23rd, about 10 days from now. Also, with approval, as an undergraduate student, which I believe we have some of you guys here in this session today, you can get approval to join these classes as well. And you have much to learn from all of them. Again, do talk to your advisor and join us for what is something of unprecedented value here in this department. I do see we have questions in the chat. I am near the end. We'll address them in just a couple of minutes, all right? We, of course, got to talk about the bureaucratics of this certificate program here. Some of the requirements that you see on the slide. There are 3 core courses that everybody pursuing the certificate must take. They are listed at the bottom of the slide there. And then you have a list of elective courses that you can choose from, adding up to 6 hours in order to achieve or be awarded a total of 15. And at the very end, have a certificate, a physical certificate in systems engineering actually mailed to you. Now, these 3 core courses that you see described down there must be taken again by anyone pursuing the certificates. They are required. It all begins with a very comprehensive introduction to the science of systems engineering, and this is the one I'm doing right now in the fall of 2021. Then it jumps into a second course that we plan to offer in the spring of 2022 that sort of strengthens the discussion on systems requirements and how to manage a system through its entire life cycle, ending eventually with a final course that Todd is offering, or Dr. Easton is offering right now, on systems integration, which ties everything together and applies it all in a semester project. So it is pretty much a project-based course that we finish the certificate with. We do have an extensive list of electives. They are on the website. They're also on the screen right now. 6 credits of elective hours are required for the certificate. We say pick 2 up there at the top, but be mindful that some of these courses do not award 3 hours. So just make sure you have 6 at the very end. On the bottom right-hand corner, there are a few things that you have to pay attention towards the end of your program to make sure that you get the certificate sent to you. Important to note as well is that the 2 courses that we talked about earlier today, Todd and myself, are in this list of electives, and we highly encourage you to take them. They are highlighted in red and in bold letters towards the bottom there. System Simulation section 009 and Production Systems and Operations section 008, starting as soon as a couple weeks from now. A quick comment here that Joy asked me to make on what the difference between a certificate and a certification is. As you see on the slide, and I read, a graduate certificate is a piece of paper indicating that you took courses in a specific area and could be considered an expert or a specialist. It is not a license or a professional board certification. However, we do have a council out there, an international council that offers certifications in systems engineering. You can take them, they are exam-based. You just pass a knowledge exam and you get a professional certificates in systems engineering. There you are, in a way or another, prepared to by taking these courses that we offer as part of our certificates. So just keep that in mind. The website to the International Council on Systems Engineering is listed on the screen. They have an incredible and very useful amount of interesting resources over there. I do recommend you to take a look at them in case you want to learn even more about what systems engineering is and how it is applied out there all over the world. And last but not least for me here, wrapping up so you all can go ahead and enroll for these classes as soon as you get out of here today. I want to illustrate the relevance of systems engineering with a bit of history. As far back as we can think, the development process of a new product or a process, service, whatever you want to call it, was essentially based on this trial and error approach that you see at the top over there. From a given concept, you prototype something and test it out. If it worked, good for you. If it did not work, you learn from your mistakes and you find ways to improve what has the potential to get you closer to success. And down there at the bottom of the slide, you see what we call the systems engineering approach. This is not new. This figure was presented for the first time maybe 30 years ago in a publication, but I really consider it to be atemporal. Not only is the process significantly more complex, and perhaps I shouldn't say complex, but comprehensive, but it also includes what goes beyond design and test. It starts with the conceptualization of a system based on a set of needs, going all the way to the retirement of that system, which is something that we don't even see in the diagram, which was proposed a little more recently by researchers in the area of systems here. Of critical value on that diagram at the bottom, there are these backtrack moves that we see all over the flow. The system engineer is able to reevaluate choices that they make at any step in the process. And this is truly a systematic approach, pun intended. You would be surprised by how many people still follow the historical trial and error model, and hence the opportunity here for you and for us to train better engineers. This is what we had prepared for the general audience here. We would like to address any questions you may have. And I do see we got some stuff down the chat here throughout the presentation. So let's see what we can do about these questions. From Dave, would there be a possibility to offer this class next semester? Operations, production systems and operations, Dave, I believe it's the one you're talking about. I'm going to say no for now. We don't have the plan to offer it in the spring because we have many other classes that we would rather have offered in the spring. So the preliminary answer here is no if you do happen to be referring to the production systems and operations course. That one is happening right now. A comment from Joy, in the spring semester we have other classes. Oh, sorry, I just saw that.
Yeah, I was answering questions in the chat. Do you want to tell them just real quick what you plan to teach in the spring?
Teaching the
Since we
spring.
already decided that.
We're going to make everything official perhaps next week or so. We have a committee of systems engineering meeting, but we do have plans.
So I got an operations research class. That's that mathematical optimization stuff where you find the best solution to a very complex system. And I also have an engineering economy class that deals with money, time value of money, how much does a project cost between two different machines, which one's better, one has a life of 4 years, one has a life of 6 years. How do you compare the two and how do you make a bunch of money? It also has a bunch of personal finance stuff. How do you do your taxes? How do you save for retirement? Things like that. I don't know. It's a fun class to teach. I love talking about money. How could a class that spends the entire semester about money not be really fun to teach?
That's right. So my plan for the spring is to re-offer the fundamentals course. And this is for the first year. That's our plan. Fundamentals of Systems Engineering course is likely to happen again in the spring. And I'm also having a project management course in the spring. Am I saying that right?
You got this.
I think you were going to do the requirements
You got
engineering.
systems engineering too.
That's right. Not the fundamentals. It's the integration course.
No, that's my
The
class.
requirements course.
He's
I'm getting
got
used to
the
it.
systems requirements course.
Yeah,
You
so-
tell we haven't worked on those syllabus yet.
I can actually go back to the slide. So the requirements engineering course is happening in the spring, and I'm going to be the one to lead that effort. Sorry about the confusion here. And excuse me.
And then we had are you done? I was going to read another.
No, you wanna add
Okay.
anything in?
Oh, about the schedule? No, I was just going to go to the next question in the chat.
Yeah. And so that's
Well,
it.
someone
So the
asked if they were not a student at the U, can they take these classes and enroll in the certificate plan? You can do the entire certificate as a non-matriculated student, either applying to the university and fill out the non-matriculated student application, which it might be too late for fall, but we have another method I'm going to talk about after these questions are over for working professionals. Or you can apply to the master's or PhD program and also take these certificate courses as part of that degree and get both awarded to you after you finish the certificate requirements. And then someone's asking if these classes will be can be taken online, which they're in the middle of the day. We do have online offerings for Northrop Grumman and some other companies. We've had a program in place with them for many years where we record some classes. However, Mark, is anyone able to count those towards full-time enrollment? I think we're only opening those to full-time working professionals who are in our distance program.
I don't quite get what you're asking there. The distance program?
Like if someone's just a regular grad student, can they sign up through the continuing education?
Yeah, they could.
Method?
It'll cost them more, but they could. I don't know
Yeah,
why they
so
would.
if you're interested in that, let me know and we can see if it would be a good option for you.
If you got lots of money around, you could sign up regular and just give me the difference.
Kind of like an executive education program, which typically for working professionals. But we can talk to you about that after. Is there somewhere we can look at the prerequisites for this course? So as far as I know, they do not have prerequisites, correct? Except if you're in the capstone systems engineering integration, we would like you to have taken fundamentals of systems engineering and or requirements engineering and management this past.
That's correct.
and summer,
Yeah,
is that right?
so that's correct. So the third core course that you see at the bottom there, to enroll for it, we expect you to have taken either the first or the second. It's going to give you a very good base to actually apply systems engineering in the what we refer to sometimes the capstone course. For the electives, the two electives that we are offering right now, at least from my perspective, I'm speaking for production systems and operations here, everyone is welcome. What about simulations?
Same, everybody's welcome. So it's just that no prereqs on any of our classes except that capstone integration class.
I went from Pedro here, the other Pedro. Consider leading and communication skills my weakness right now. Will the certificate prepare me to properly interact and lead engineering groups? Also, I understand MBSC as one of the pillars of system engineering. How in depth is this covered in the program, if at all?
We can't be a good systems engineering program without covering MBSE as model-based systems engineering. So the answer is between the intro class and the capstone class, you're going to cover it. You're going to see it in a bunch of other classes, even if it's not at the same level as that. Basically, as you look at any systems engineering tool, the answer is you model almost everything. You don't want to mess with the system, because if you're wrong and you break the system, it could bankrupt your company. So no matter what you're doing, you're always building a model, whether it's the big MBSE or if it's a small model just to optimize something, but you always build a model first. And then you always have to translate into the real world. The answer is all models are wrong, but some models are useful. And we definitely want to get to that. Some models are useful because you really don't want to break a system entirely until you know exactly what's going to happen, or at least have a really good ballpark guess of it. So yes, we will definitely cover MBSE.
How about leadership and communication skills, or maybe management?
I emphasize it in all of my classes. It's not going to matter. I mean, I honestly think as you look at a systems engineer, the easy part is doing the math, the building the better system. The harder part is convincing your peers, your leaders, and the people you're trying to lead that you're right. And so I will always focus on the person, whether it's writing, whether it's talking, everything like that. So at least in my class, Pedro and I have talked about it. He feels the exact same way. And so really a substantial amount of any class is going to be focused on how do you write a good technical report? How do you convince people? Sometimes we'll have presentations, sometimes not. And if that's the case, then I'm certain that we will cover, at least in the capstone class, I know we're going to cover presenting. How do you present a good presentation? Because we need people who can go out and make changes, or else there's no sense in being a systems engineer.
Great. Does anyone want to unmute themselves and ask a question, or any more questions you want to throw in the chat?
I'm curious if this program can start off at the certificate and then later you can transfer in and apply to the master's degree for it.
So any class that is a certificate class can also count towards a master's degree. In my interview, I talked about trying to start a master's program. It is not trivial to start a master's program. You got a bunch of forms to fill out, but that is certainly one of my goals. My goal honestly would be to have a master's program in place within 2 years, but there's votes by faculty, there's votes by the college, there's votes by all sorts of other people. And whether that becomes a reality or not, I have no idea. But it is certainly one of my goals, and Pedro's. We both talked about it. One of the comments I mentioned is that there are more graduate degrees than undergrads. At the core of systems engineering is this idea that people want to gain that knowledge when they go into leadership. And so if we're going to have a good program here, I really think that we need to try and push for that. But you can't guarantee something that doesn't exist in a university, because there are always issues. But my goal is to get one started here reasonably soon. And I don't know what that means, because academia is kind of slow. Mark may have a comment about that too, since it would have to go through him and the grad committee and things like that too. So
I have a comment. You can complete the whole certificate as a non-matriculated student. However, if you wanted to continue on to a master's degree then or in the future, you can only count 9 non-matriculated credits towards a master's degree. So as you're going through the certificate, you kind of have to make a decision. Do I just want this certificate? Am I going to stay non-matriculated? Or do I need to apply to the master's degree program if you're in that second or third class and you're going to be finished with those 9 credits? to move any further to be able to count everything towards a master's degree, you need to apply at that point. So keep that in mind. Also, like you said, we don't have a specifically master's or PhD in systems engineering at the moment, but if you look at the amount of electives and core classes that we have, you could essentially complete your entire master's degree in systems engineering and say that you concentrated it or had an emphasis in this area. We might call it a track or a focus area or something along those lines. So
Absolutely. And fundamentally, you should get a master's in mechanical engineering now with a certificate in systems engineering. That's the current path right now, for sure.
Any other questions? We do have can you throw that contact info slide up again?
Yes, let's get there.
Feel free to email, if it's related to a master's degree, you can email Dr. Felberg, who's on the line, m.felberg@utah.edu. I'm a general good person for questions. And then if you have questions about the classes or the certificate or future offerings, email the professors. We don't have any other questions. There's a couple more slides. If you're just a working professional not enrolled at the U right now, we will talk for a minute about our online distance classes. What are some of the industries? We have a question again from Pedro. What are some of the industries that are mostly interested in systems engineering professionals?
Oh, I'm going to say all of them. And this is an easy answer. All of them.
Walt Disney World. There you go. Go work for Disney and teach people how to make shorter lines and which ones are valuable. Placed a bunch of students in Walt Disney World. People go work for all sorts of companies. It's so cool as all the different companies. People got to work for a mountain bike company. They build mountain bikes and figure out how to make them better. I mean, just like all over the place. That's my favorite part of systems engineering by far.
It's a huge deal in the healthcare industry right now as well, and it has been for maybe more than a decade. Hospitals are hiring systems engineers like crazy. And as you saw in the first slide, let me get there real quick. We have, as defined by the United States Bureau of Labor Statistics, a much faster than average job growth rate projected for, I'm going to say, the next 8 years or so. From 2019 to 2029, 10% is the growth in job availability for an industrial and/or systems engineer. Mechanical engineers are seeing some growth as well, about average compared to all of the areas out there, about 4%. Industrial and/or systems engineer, 10%. And that's a crazy number if you ask me. Sorry, Joy, I got out of your slide here for working.
That's okay. It was not quite. It seemed like we still had 4 questions, so you could leave it up on the contact slide.
Okay.
A quick question, if that's okay. Sorry.
Yeah, go ahead.
So I know it was mentioned earlier. I was just wondering if we could get some more clarification with these classes being in the middle of the day. Are your slide decks just going to be available? If we are working full time, can we still take these classes? And are we expected to be in class every day? Or are we going to miss a whole bunch if we can't be there?
So I'm going to record every class and post it to Canvas. That is my plan. So you're not just looking at the slide deck, you'll be looking at the actual lecture.
Awesome.
I have no idea what the policy is at this university for it.
Yeah, so we're not authorized to offer fully online classes except with the COVID exceptions that we got last year. So we're not technically authorized to schedule it as an online class and offer it online just because of ABET and other accreditation rules of people taking classes in different states or just all kind of weird accreditation issues. But like I mentioned, we are expanding our distance program that we have through Northrop Grumman. So that is the main reason they'll be recording these courses. Northrop Grumman is a huge employer pushing systems engineering. So they'll be recording the lectures for that class. I think it's up to them if they want to post every lecture, make it available to every student. We're not widely publicizing that the classes are available online because they're not really online for current grad and undergrad students.
So the classes are available online, but you have to enroll through continuing education and not just the regular place. Is that right, Joy?
Technically, yes. We have a registration link that is through continuing education. It's $2,500 per course, and it's an online section of the course. And typically it'll be Northrop Grumman employees, possibly people from L3Harris or other government contract type employees. But then if you're enrolled in the regular section, that would be up to the instructor if they're going to require attendance allow people watching the online lectures. It's kind of a gray area at the moment.
Well, it's also great because you don't know what's going to happen with COVID either.
Yeah,
so
exactly.
you can kind of guarantee that somebody's going to be quarantined in my class, guaranteed. And in every
Yeah.
class, there's going to be somebody who's going to be quarantined, and they're not going to be able to come to class. And so the fact that we're recording will at least let you keep up with class if that happens too. So.
Okay, that answers my question. Thank you.
Any other questions?
I think there's a couple in there. So about job opportunities in the state of Utah, I don't have concrete data yet. So this is something that we'll collect over the coming weeks, but I can tell you there's a lot, especially around the Air Force Base. I've worked for 3 years at the University of Oklahoma in many, and I'm not saying 1 or 2, but many of the students I graduated in Oklahoma found jobs with the contractors of the Air Force Base here in Utah, in the Salt Lake City area. So keep that in mind if you just want to work 30 minutes up the road. There are opportunities out there, and they are in fact the driving force of this program here right now. And then about summer classes of 2022, we are in the process of planning. We are not entirely sure what will be offered in the summer, but that information will be out as soon as we know. Correct?
Given it's a graduate program, I kind of doubt that any of the classes we're offering, any of these 2 semesters will also be offered in the summer. Maybe the fundamentals class, maybe not, but at the core of it, it'll probably be new classes to
Probably
try and
electives.
provide more availability for more topics and things like that. That's kind of, so I'm not sure what's going to be offered, but it's not going to be the operations research or the engineering economy or my integration or the simulations class for me. So it'd be more
All
systems
classes that will
engineering.
count as electives for the certificate, and then there would typically be an undergrad technical elective section process.
Yeah.
Um,
You know, those choices are sometimes demand driven. For instance, I know that the fundamentals course was offered this summer. And if there is a need, we may consider offering it again next summer. But it's going to take us a few more weeks to figure that one out.
That would be the one class that would be double offered in any given year, is the fundamentals class, for sure. I don't think any of the other classes would. So.
mhm. We'll probably, once they get the schedule kind of finalized, we'll probably post a yearly glance on the website for the systems engineering courses once we have that nailed down. Anything else pop up? How hard the classes will be?
That sounds like a Pedro question. How hard are the courses? Mine, they're a piece of cake because I teach them well and they're super interesting and they're fun and you're going to enjoy taking them. And that's what gives you an A or A+, when you enjoy taking the course you're taking. I don't know about you, Todd.
You know, my classes, so I've never taught the systems engineering integration class. That class is going to be case-based and project-based. And so my goal here is not just to have you learn something, but to keep whoever is providing the project happy. And so some projects may require more work, some may not. It's tough to know. It's supposed to be the capstone of the systems class. So it's tough to say on that one because I don't know what projects I'm going to have. I've only been in town for a couple of weeks. And so it kind of is based on that, but I will try and make sure it is a reasonable load. I believe in the definition of a credit hour. I believe that 3 hours of credit is 3 hours of credit. That is my belief on both ends. A class that doesn't take that full time is also kind of a disservice to you because you're not learning as much. A class that is over that is also a disservice to you because you're spending too much time on any one class. So I prefer to be on the intellectually challenging side more so than the labor intensive side. I want you to have to think and develop brain cells and figure out how to think more than to sit there and do a bunch of mundane work that's just repetitive again and again and again. Things you can kind of guarantee. I would never give you 2 of the exact same homework assignments. You do one problem, I assume that's sufficient. So I don't know. I mean, some of my classes have been called really, really hard, but that's on the intellectual challenging side. Very rarely are my classes called very, very time consuming.
Homework intensive?
Not for my class. Oh, at the simulation class, it's a bunch of projects and it's a computer modeling software. So it's, I don't know, anybody's ever done computer programming. I can get it done really fast. I will try and not make it too hard, but it can be really, really frustrating too. As you're trying to debug something, you're sitting there like, why doesn't this do this? And so that's one that can be intensive. both my classes might be. Again, it's tough. It's a tough call. In the end, I believe that when you're computer programming, there is a fine line between seeking help and not. You should be frustrated. If you start to become irate, you need to seek help immediately, because the answer is usually right there. And it might be something as simple as a comma or a missed tab if you're in Python or something that's just trivial to see. And sometimes you need a new set of eyes. So generally, I've talked to Pedro about this. Our office door is usually open. You know, we will have our normal office hours where we'll be here, but we want people to stop by. You know, it's part of just building good communication skills and things like that. And we're happy to generally help out whenever.
Great. Anything else? Okay. People that got the information they need, feel free to jump off. If you're a working professional and want to hear the last 2 slides regarding our online program that we've had through Northrop Grumman, or if you're interested in that in the future, feel free to stay on. I'll send out this PowerPoint and recording to everyone and post it on the website as well. So we've had this systems engineering certificate for many years. We started with orbital ATK way back in like the early 2000s, kind of died out when we lost the faculty, but Northrop Grumman students have been taking online master's courses ever since then. Basically, there's a coordinator there that sets up which classes they want to take, and we record it. They get their whole master's degree this way. We've now, with the hiring of the 2 new faculty, we're trying to expand this option. We have a method where you can register through continuing education as a non-matriculated student. You don't have to apply to the graduate program. You don't have to apply to the university, so it's easy to do it now. You can do it up until classes start. Just get registered, and you'll get manually enrolled into the courses by the continuing education office. You can email me for the link if you're interested in doing that. It's $2,500 per course, which is the amount Northrop Grumman reimburses through their tuition reimbursement program. Other employers might have different policy, either prepaying or reimbursing for tuition. It is considered 100% tuition. It's about the same cost as taking 1 graduate course with the full fees, if you were to just take 1. However, if you're adding multiple courses, it's a little bit cheaper to take it through the normal registration method. But for that, you have to get applied and get admitted and all that. They do award graduate credit. You could complete the entire certificate this way without ever applying to the university. You could apply towards a master's degree. We offer other courses to them. If they get at least 6 students, then we set up a distance section, and we have students doing an entire master's degree. Keep in mind, like I mentioned earlier, that you can only do 3 classes as a non-matriculated student, so you could get started in the fall, apply for spring for the master's program if you want to enroll in the master's degree. Also keep in mind you need a B or better for non-matriculated classes to count towards a master's degree. Otherwise, it's B- once you're admitted and enrolled. So it's a little bit different requirement because you're technically transferring them to the master's degree. Okay, next. So for this fall, in addition to the 4 systems engineering classes, we'll have 2 to 3, well, we normally have 2 to 3 additional courses available to the online method. So this fall we have design implications for human machine systems, which can count as an elective for the certificate. I noticed it wasn't listed. And then the object-oriented programming for engineers is actually online for everyone. They set it up that way for fall through an exception. So that one's also available through the non-application method. So my email is joy.velarde@utah.edu. Does anyone have questions about this program or registration method? Pretty good program. A lot of people have gone through it. We're trying to expand it. So that's a quick way to get involved without having to apply.
I don't see programming on the list on the website.
On the regular course schedule. It might be called Programming for Engineers. And I might have
I think it's 5250 is the under one.
Oh yeah, sorry, 6250.
6250.
Yeah, MEN 6250.
Yeah, I don't see that on their list on the certificate.
For the Northrop Grumman list?
Oh,
these are just courses that we're offering online. I just want to mention it because it's registering the same way that you could register with systems courses.
but it's not counting as one of the electives to systems.
No, that one's on the systems elective. It's just an additional online course, but you can count the design implications. There's also some other fall courses if you're just a regular enrolled graduate student and could take the times listed on the schedule. There's product safety is an elective. It's available. So some of the ones you see on the elective list are available. They're just regularly taught through professors that are already in our program. So you might want to see what else is offered that you could count. And then spring, we always have things. We also have ergonomics in the fall. That's an elective. Spring, we've got industrial safety and things like that. Those are all electives. And then someone's asking what software will be used. Todd, do you want to?
I'm going to use Arena for the system simulation class. I'm going to try and use SysMill for the integration class. Anything you're planning on using?
Definitely spreadsheet software. This is something that is used across the board, and you would be surprised. I once read a statistic, and I'm unfortunately unable to remember where it came from, but 80% of the decisions that drive the future and the direction of corporations across the world are based on spreadsheets. So Excel is literally running the world right now, and we underestimate how big it is, how important it is to work with spreadsheet software, because 80% of decisions that drive the future of corporations are made using Excel. It's incredible. So this is what I extensively use, at least on my courses, and this is what you're going to see in production systems and operations, and the fundamentals by all means for assignments.
So Arena, Excel, was there another one? Someone wanted me to type in the chat. Did I miss the name of a software?
Yeah, SysML. It's a systems language. Pretty interesting.
Thanks, Pedro. All right, any last questions?
So what's Excel mainly used for? For requirements or
Excel?
actually SysML?
So what was your question? I'm sorry.
So how is Excel used in a systems engineering context? It's like primarily for requirements or for SysML modeling, such thing?
For pretty much anything you can imagine, data analysis, optimization, because Excel has powerful optimization tools. In my production systems and engineering course, production systems and operations course, you will use Excel to run simulations that could also be run using Arena, but we run in spreadsheet form, which is pretty cool to see by using random number generation, et cetera, et cetera. So literally everywhere. I promise you that Excel will be in many of my assignments, no matter the course I'm teaching.
Great. I know Pedro's really interested in Cameo. We put Cameo question mark, but I know we went with Arena. But does it be an opportunity to learn Cameo in the future? Do you know?
That was a debate early on when we were getting hired. I don't know what happened to the Cameo. That kind of just I needed Arena for my class, which is totally different than Cameo. As I was reading it, SysMill is kind of, it's the one that's free.
Yeah, I think we looked into the Cameo license and the wrong person from the vendor. Like, it's a huge company and they thought we were talking about some other program, and I said no, this program. So maybe in the future, but not this semester.
They didn't have an academic license, which made Cameo really hard to use in an academic setting. I mean, Arena, we got like 30 licenses for all year, and we only have to pay $500 every year to keep them renewing. And, you know, so they had that, but Cameo didn't have an academic license. And I think that really caused a problem just trying to get it.
Great.
This KIB is what we use here in my work.
Great. So you'll hopefully be able to learn it.
I think there's a lot of overlaps between Cameo and SysMill. Cameo has more features and has the ability to do other stuff like that, but so I'm not particularly a software person. I believe that what you've got to learn is the tools, and then it takes a couple days to learn the software. Does that make sense? Like, I'm teaching Arena, but there's Simio and there's Simulate, and there's like 20 or 30 other simulation softwares. I'm just choosing to teach Arena because I like it better than a lot of the other ones. And you should be able to take the knowledge from the class and be able to transfer it to whatever type of software you have. And so I'm very convinced that even though we're not covering Cameo, you're going to be able to transfer the knowledge from our classes into Cameo.
Which is obviously more important than learning the tool for sure.
Yes, because you can learn software pretty fast, but getting the knowledge of what to do, and it's a little frustrating when you try and switch. I kind of view it as like switching from C to Python. You know, I used to code in C, and yeah, it was painful to switch to Python, but I'm really glad I did. And I kind of view that as the same thing. You're gonna learn SysMill is kind of the one that started earlier. It's a little bit, I'm sure it has less bells and whistles than Cameo, and it'll, you know, but by learning those fundamentals, I think you'll get way better at Cameo really fast.
Awesome. Anything else? It's been a lively discussion. Thank everyone for their participation. And I'll end the presentation here. Thanks, guys.
Thank you.
Thank you all. Please enroll.